Hi, my name is Shahroz Ahmed, and in this video we are going to start off with the topic of GCSE chemistry, and that topic is about the bonds. So in this topic we'll discuss about the chemical bonds, which has three types of bonds, that are ionic bonds, covalent bonds, and the metallic bonds. So let's start off with the chemical bonds, but before that let me discuss why the atoms form the bonds, or what and how a bond is formed. So let's start off. So basically atoms, they form the bonds to stabilize themselves, and they form bonds through the movement of the electrons with the other atoms. So let me just write it over here. Why atoms form bonds? So atoms form bonds to stabilize themselves. That's the one-liner answer. To stabilize themselves. So this is the reason that the atoms form bonds. And the next question should be, why atom, or how atoms form bonds? So let me just write down here how atoms form bonds. So the atom form bonds through the movement of electrons with other atoms, and this phenomena is called chemical bonding. So let me write it over here. So the atoms form bonds through the movement of electrons with the other atoms, and this phenomena of bond formation is called chemical bonding. And the bond that forms between the atoms, they are called the chemical bonds. So this is called chemical bonding. All right, so now let's discuss the types of chemical bonds. All right, so we have three types of chemical bonds. Number one, ionic bonds. The other one are the covalent bonds, and the third one is the metallic bond. So what happens in ionic bonds? Let's discuss them one by one. So the ionic bond, it is formed between two atoms, or just I can write between the atoms, by the transfer of electrons. By the transfer of electrons. So such a bond is called the ionic bond. For example, let's suppose we have two atoms. The first atom is sodium and the other one is chlorine. So in the outermost shell of the sodium there is one electron, and I'll represent the electron with black color. In the outermost shell of sodium there is one electron, but in the outermost shell of chlorine we have 7 electrons. So let me just try to denote them by cross. I'm only talking about the outermost shell. There are more atoms like in the inner shells, but I'm only talking about the outermost shell. So it has 7 electrons in its outermost shell, but sodium has 1 electron in its outermost shell. So before explaining the ionic bond, we have to discuss how an atom becomes stable. So an atom becomes stable if it has 8 electrons in its outermost shell, except hydrogen and helium. Hydrogen needs 2 electrons in its outermost shell, and helium is already stable. So all other atoms need 8 electrons in their outermost shell to stabilize themselves. So in this one we have 1 electron in the outermost shell of sodium, but there is an inner shell of sodium that has the 8 electrons. Like there's an inner shell of the sodium which will have 8 electrons in it. So 1 2 3 4 5 6 7 8. So over here sodium is not stable, neither chlorine. So it is easier for sodium to give 1 electron rather than accepting 7 electrons, and it is easier for chlorine to accept 1 electron rather than giving out 7 electrons. So what will happen, this sodium will transfer 1 electron from itself to chlorine, and this outermost shell will be gone, and the new shell that will be exposed by the sodium will have 8 electrons in its outermost shell. So in this phase the sodium will have 8 electrons, and the chlorine will accept the electron of sodium, and it will also have the 8 electrons. So both have 8 electrons in the outermost shell, so both will become stable. So this is how the ionic bond is formed. by the transfer of electron from one atom to another. Okay, so if there are 2 electrons in the outermost shell of an atom and there are 6 electrons in the outermost shell of an atom, then what will happen? The atom with 2 electrons will give its electrons to the atom with the 6 electrons in its outermost shell. Alright, so this is the simple example and definition of the ionic bonds. Let's discuss something more about the ionic bonds. So the ionic bonds, basically these forms are the strongest of all, and they have the strong electrostatic forces between the atoms, and they form the lattice structure between the atoms. So let me just write down the properties of the ionic bonds. They have strong electrostatic forces between the atoms. Electrostatic forces, and they form lattice structures. Lattice structures are the structures that are that have fixed proportion, they have fixed shape, they have high melting and boiling point, and it is very hard to break the lattice structure. So because they are the strongest bonds, so they form strong lattice structures. Alright, and usually they have high melting and boiling points, because the atoms in the ionic bonds, they are bonded by the strong electrostatic forces. So they have high melting and boiling points. Alright, so these are some of the properties of the ionic bonds. Now let's see how we can name the ionic bonds. Alright, so we have to see the naming of the ionic compounds. So the compounds that are formed by the ionic bonds, they are called the ionic compounds. And let me just write down some ionic compounds, and let's see how we can name them. So NaCl, KCl, and NaNO3, CaCO3, and one more, I'll write it here, MgCl2. Okay, so you see in the ionic compounds, the first atom is usually the metal, and the other atom will be the halogen or some polyatomic ion. So in order to name them, we'll write the name of the metal as it is. So this is sodium, so we'll write sodium. And if we have the halogen are basically the atoms that belong to the 7th group in the periodic table. So over here it's chlorine. So this chlorine will become chloride. We will add IDE at the end of the name of chlorine, so it will become chloride. Similarly, if it is fluorine, it will become fluoride. If it is bromine, it will become bromide. If it is iodine, it will become iodide. So we will add IDE at the end of the halogen atom. And this is the metal, so it will be potassium as it is. And this is chlorine, so because it's a halogen, it belongs to the 7th group, so it will become chloride. Over here, the metal will remain as it is, that is sodium. And this ion is a polyatomic ion, so the ion that have the oxygen atom in it, it will become nitrate. It will have ATE at the end of their name. It will have ATE at the end of their name, so it will become sodium nitrate. Alright, similarly this one, it is calcium as it is. This polyatomic ion has name carbonate, ATE, so it will become calcium carbonate. Similarly, this one is magnesium, and it has chlorine as the other atom, so it will become chloride. So remember that an ionic bond is formed between a it is usually formed between a metal and a non-metal. And when the bond has been formed, then the metal gets positive charge because it loses the electron, and the non-metal gets a negative charge because it accepts the electron. So in this one, their valency will be the valency of the metal will be positive. For the non-metal, it's negative. So it's positive, negative, positive, negative, positive, negative, positive, negative. Same goes for here. All right, so this is how the charges will be on the ionic compounds. So this is it for the ionic compounds. Now let's move on to the covalent bonds. So covalent bonds. So unlike the ionic bonds, the covalent bonds are formed due to by the sharing of electrons between the atoms. So let me write down the definition first, and I'll explain it to you. So the bonds that are formed by the sharing of electrons are the covalent bonds. For example, let's take the example of carbon. The carbon atom belongs to the fourth group of the periodic table, and it has 4 electrons in its outermost shell. 1, 2, 3, and 4. Now, in order to stabilize itself, this carbon will form bonds with the other carbon atoms. So now it is very hard for these carbon atoms to accept 4 electrons, and also it is very difficult for this carbon to give 4 electrons. So what does it do? It forms bond with 4 other carbons. So this is one carbon, here's another one, and this is the 4th one. So these carbons have also 4 electrons in their outermost shell. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So in this one, this central carbon will form bonds with the other 4 carbons. So in this way, this carbon will share 1 electron of this carbon. In this bond, this carbon atom will share 1 electron of this carbon. In this bond, it will share the electron of this carbon, and similarly in this bond, it will share the electron of this carbon. Now you see, around this central carbon we have 8 electrons, and as I have told you that in order for an atom to become stable, it needs 8 electrons around in its outermost shell. So this carbon has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. So now this central carbon has stabilized itself. In the same way, the other carbons will form bonds with four other carbons, and then this structure will keep on going. So these type of bonds that are formed by the sharing of electrons, they are called the covalent bonds, and usually the covalent bonds are formed between the non-metals. So they are usually formed between the non-metals, and they are weaker than the ionic bond. They have low melting and boiling points, and it is easier to break them as compared to the ionic bonds. Okay, so let me just write it here: low melting point and boiling point, and weaker than ionic bonds. So it is easier to break the covalent bonds. Now let's discuss the types of covalent bonds. There are 3 types of covalent bonds: the single covalent bond, the double covalent bond, and the triple covalent bond. So let's discuss their types. Alright, so let's discuss about the single covalent bond. So the single covalent bond is the bond that is formed by the sharing of only 1 electron. For example, consider the case of hydrogen. Hydrogen has 1 electron in its outermost shell, and I have told you that hydrogen needs 2 electrons in its outermost shell to stabilize itself. So in this one, these hydrogen atoms will share only 1 electron to stabilize themselves. It will be here. So this type of bond is called the single covalent bond. And the bonds that we have seen till now in the previous example, it was also the single covalent bond. Alright, now let's discuss the double covalent bond. Alright, so the double covalent bond is the one that is formed between the atoms by the sharing of 2 electrons. Consider the case of oxygen. So this is oxygen. It has 6 electrons in its outermost shell. So I'll just 1, 2, 3, 4, 5, and 6. And there's another oxygen atom which also has 6 electrons in its outermost shell. So I'll mark them with cross: 1, 2, 3, 4, 5 and 6. So what will happen? They will share 2 electrons with each other. This is the 1 electron, this is the sharing of the other electron. So this type of bond is called the double covalent bond, where the 2 electrons are being shared to make the bonds. Why they have shared the 2 electrons? Because they had 6 electrons in their outermost shell and they needed 2 more electrons to stabilize themselves. So in order to do that, they had shared 2 electrons. So we can represent it as O with 2 lines. Oh, these 2 lines are showing the double covalent bond. Now let's discuss the example for the triple covalent bond. Okay, so the triple covalent bond is the one that is formed by the sharing of 3 electrons. Let's take the case of nitrogen. So nitrogen is the atom that belongs to the 5th group. It means that it has 5 electrons in its outermost shell. So 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. So now they will share their 3 electrons with each other to stabilize themselves, because both the nitrogen needs 3 electrons to stabilize, 3 more electrons to stabilize themselves. So 5 plus 3 will become 8. So this will be 1 sharing, here will be the other sharing, this will be the 3rd sharing. So they have shared 3 electrons with each other to stabilize themselves, and such a bond is called the triple covalent bond. So it is represented by these 3 parallel lines, and this is called the triple covalent bond. Now, triple covalent bond is weaker than the double covalent bond, and the double covalent bond is weaker than the single covalent bond, and the single covalent bond is weaker than the ionic bond. So this is the trend that you have to keep in mind. Now after this one, let's discuss the metallic bonds. Now the next type of bond are the metallic bonds. They are quite interesting and different from the ionic bonds and the covalent bonds. The metallic bonds, they are formed by the availability of the delocalized atoms within the metallic structure. So let me just write down the definition first, then I'll explain you how they are formed. So they are formed between the positive metal ions and delocalized electrons in the metallic structure. Delocalized electrons in the metal. So consider a metal like this. This is a piece of metal. It has the positive electrons and the delocalized positive ions and the delocalized electrons. So the positive ions will be like this. These are the positive ions in the metal. Alright, so they have positive charge. And now we have a sea of electrons that are available around these positive ions. So we have the electrons, they are just randomly moving around in the metal. So these are the electrons that are just moving around. So what happens is each positive ion has the availability of so many electrons in itself. So that's why they form a very strong bonds, and those bonds are called the metallic bonds. These electrons are free to move. That's why the metals are good conductor of heat and electricity. They have the strong electrostatic forces between the positive ions and these delocalized electrons, so they have high melting and boiling points. So I'll just write the properties over here. They have strong electrostatic forces, that's why I'll just write it over here. That's why the metals keep a definite shape. The metals keep a definite shape. The next point that you have to remember is they have high melting and boiling points. They have high melting points and boiling points. MP means melting point, BP means the boiling point. And the last one, that the point that you have to remember is they are good conductor of heat and electricity because of the delocalized electrons. They are easy to move around, so that's why, because as we know that electricity is conducted due to the motion of the electrons or the motion of the charges. Because these electrons are free to move from one place to another, so they perform as the good conductor of heat and electricity. So they are good conductors of heat and electricity. I'm talking about the metals, good conductors of heat and electricity. So this is it for the topic on bonds. We have discussed the ionic bonds, the metallic bonds, and the covalent bonds. So now let's move on to some exam related questions and let's see how it goes. Alright, so here we have an exam related question. In this question it says the arrangement of electrons in a sodium atom can be written as 281, which represents the atom's electronic structure. Write the electronic structure for an atom of potassium. So this is for the atom of sodium, and now we have to write down the electronic structure for potassium. So potassium has 19 protons. Its atomic number is 19. It has 19 protons and 19 electrons. And so let's write down the structure of the potassium. It will be like this: 2 8 8. So 2 plus 8 is 18. So 2 plus 8 is 10, 10 plus 8 is 18, and then 18 plus 1 will be 19. So this will be the structure of potassium. The only difference between the sodium and the potassium is that it has one more shell around its nucleus. Now let's move on to part B. It says the electronic structure of sodium atom can also be shown using an electron shell diagram as shown below. Repeat the drawing for a chlorine atom to show its electronic structure. So we have to repeat the drawing for the chlorine atom. Alright, so chlorine has 17 electrons around it. We have to arrange these 17 electrons around the nucleus. So let's suppose this is the center. This is chlorine. This is the first shell. Here it is the second shell. So in the first shell there can be maximum of 2 electrons. So 1 2. In the second shell there will be 8 electrons. So let me just write down the electron arrangement over here first. So it's like 2 8 and 7. 2 plus 8 is 10, 10 plus 7 is 17. So we'll have 2 electrons in the first shell. In the second shell it will have 8 electrons. 1 2 3 4 5 6 1 2 3 4 5 6 7 and 8. Now I'm going to draw the next shell. That will be the outermost shell. So here we have the outermost shell. So in this outermost shell there will be 7 electrons. So it will be like 1 2 3 4 5 6 and 7. So this is how we can draw the electronic shell diagram for the chlorine. Now let's move on to next part. Alright, so in this part it says draw a similar diagram to show the electronic structure of the particles in sodium chloride. Indicate how the molecule was formed from the ions. Okay, so we have to draw the diagram for the sodium chloride, and we have to show how the sodium chloride has been formed. So let's draw the structure for the sodium and then for the chlorine, and then okay, over here I'm just gonna make the outermost shell. In fact, let me just make all the shells. So this is the first shell, this is the second shell, this is the third shell of sodium. The electronic configuration of sodium will be like this: 2 8 1. Electronic configuration for chlorine will be like 2 8 7. this is sodium, and over here we'll have chlorine. So here's the first shell, the second shell, and the third shell. This is sodium. Alright, so now let me just draw the electrons. So I'll mark the dots for the sodium and crosses for chlorine. So 2, 8, 18. So in the first shell it has 2 electrons. In the second shell it will have 8 electrons, 1, 2, 3, 4, 5, 6, 7, and 8. And in the fourth shell, like in the third shell, it will have only 1 electron. Now let's see for the chlorine. So chlorine has 2 electrons in its first shell. It has 8 electrons in its second shell, 1, 2, 3, 4, 5, 6, 7, and 8. And it will have 7 electrons in its outermost shell. So 1, 2, 3, 4, 5, 6, and 7. Now this electron will move over here and it will form a bond. So in this way the sodium chloride molecule will be formed. Alright, so this is it for this question. Now let's see another one. Alright, so here we have the next question. In this question it says the ionic lattice structure of sodium chloride is shown in the diagram. Complete the table. Name of the ion and charge, name of the ion and charge. So there are 2 ions over here. One is sodium, the other one is chloride. So this is sodium over here. And the charge on the sodium will be +1 because it loses 1 electron. So it loses 1 electron, so it has a deficiency of 1 electron. So its charge will be +1. Now for the chloride, it will have a charge of -1 because it accepts 1 electron. Okay, now in part B it says using the diagram in A to help you describe the nature of the chemical bonding in ionic structures. So in ionic structures they form giant lattice structures with alternative positive and negative ions. So I'll write it over here. They form giant lattice structures between the positive and negative ions. Positive and negative ions. The next thing that you can write over here is they have strong electrostatic forces between them. Strong electrostatic forces. Between their positive and negative ions. The third one is the forces act in all directions so that they maintain their structure. The forces act in all directions so they can maintain their structure. Maintain their structure. So these are the 3 points that you can mention in order to explain the nature of the chemical bonding in the ionic structures. Now let's move on to the next. Alright, so in this part it says identify 2 assumptions that the diagram in part A makes. So let's go on to the diagram and let's see what are the assumptions that we have made that may be incorrect. So in this diagram you can see the size of the sodium and chloride, it is not drawn to the scale. So we can consider this as the chloride and this as the sodium. So their size is not this, their size may or may not be same. So you can say that the size is not drawn to the scale. The size is the size of sodium ion and chloride ion is not drawn to the scale. Drawn to scale. The second assumption that you can take over here is the empty spaces between the ions. Over here we can see the empty spaces between the ions, but in reality there are no empty spaces between the ions. It's a fixed structure. It's a very solid structure without any empty spaces. So this is the second assumption. There are empty spaces between the ions. In reality, there are no empty spaces. Empty spaces between ions. Alright, so these are the two assumptions that you can take for this model. Now let's move to the next. Alright, so in the next part it says calcium metal combusts in oxygen, produces calcium oxide. We have to balance the equation. So in this equation we have to balance it. So we can see over here on the left side we have calcium, 1 atom of calcium and 2 atoms of oxygen. On the right side we have 1 atom of calcium oxide, so I'll write 2 over here, so and 2 over here. So in this way we have 2 calcium on the left side, 2 calcium on the right side, 2 oxygen on the left side and 2 oxygen on the right side. So it's balanced now. The next part it says describe what happens when a calcium atom becomes ionized. So when a calcium atom becomes ionized, calcium, it belongs to the second group, so it has 2 electrons in its outermost shell. So calcium loses 2 electrons from its outermost shell, and when it loses 2 electrons from its outermost shell, it has deficiency of 2 electrons, so that it will have a charge of +2. So calcium ion has +2 charge due to the deficiency of 2 electrons. Deficiency of 2 electrons. So these are the reasons that you can write for it, and this is it for this lesson, and I hope you understood it. So we have discussed about the bonds, the type of bonds, and did some exam related questions, and thank you so much for watching.